Hello student. Student, in last video we have discussed about the dimension. Okay. So today I am explaining you this topic again by giving some examples. Then we will study the principle of homogeneity and the application of dimension or application of principle of homogeneity. Okay student. So I have told you the dimension means these are the powers of fundamental physical quantity which are used to represent any other physical quantity or any other derived physical quantity. What? Powers of fundamental physical quantity which are used to represent any derived physical quantity. Okay, so I am taking some other example like uh, student, very common formula we have studied in class ninth, that gravitational force F equal to G m1 m2 over r square. So today we will find out the value of the dimension of this gravitational constant capital G. So what will be the value of G? It will be F r square m1 m2. If you know the dimension of F, you can calculate it directly. In last video I have told you the dimension of F is mlt minus 2. Dimension of r means distance. Dimension of length, then this distance means length, l square. m1 means m is mass. Dimension of mass is m. So we can cut this m by this. So by solving this, when it will goes up, m power minus 1, l power 3, t power minus 2. So dimension of gravitational constant is m power minus 1, l power 3, t power minus 2. So its meaning is to represent gravitational constant we use this mass is the fundamental physical quantity. So we use mass one time and we use length three times and we use time two times. Okay, so I have told you dimension means number of powers of fundamental physical quantity, means how many times we have used that fundamental physical quantity to represent this derived physical quantity, because the mass is the fundamental physical quantity, length is the fundamental physical quantity, time is the fundamental physical quantity. This one is very easy. I think you all beta, I have written a dimension of force directly. Okay, because I have already told you, if you don't know, you just watch my last video, then you will know how to find the dimension of force. Okay, yeah. I am giving you one more example, because in last video when I have sent you in WhatsApp group, I have given PDF notes. In that PDF notes I have given all the derived physical quantity along with their units and along with their dimension. I hope you all have written all those quantity in your notebook. So I am giving you one more example. I am taking one more example. Eta. This is uh, this is called viscosity coefficient. You will study in next chapters. Maybe no. You will study in second book, in volume second. What it is? Eta is called coefficient of viscosity. Its formula is F upon A dv over dx. Okay, I will tell you what is the meaning of viscosity and what is the coefficient of viscosity. We will discuss it later when it will come. Okay, but here we are finding the dimension of coefficient of viscosity. So formula of coefficient of viscosity is force upon area upon dv over dx. This dv over dx is called velocity gradient. What? Velocity gradient. Beta, meaning of velocity gradient means change in velocity with respect to distance. Whenever any physical quantity change with respect to distance, that is called gradient. Means temperature gradient means change in temperature with respect to distance. Similarly, potential gradient E equal to dV over dx, change in potential with respect to distance. Whenever any physical quantity change with respect to distance, that is called velocity gradient. So student, for simplicity, I am finding the dimension of dV over dx first. What is dV? Change in velocity. You simply write it v over x. Velocity upon distance. Student, what is the velocity? Displacement upon time. What is x? Distance. Displacement means length. Unit of dimension of displacement will be L upon time upon L. Okay. Beta, displacement means length. Length is, I have already told you, length is measured in meter, and meter is the dimensional symbol for meter is L. Time is measured in second and its symbol is T. Distance means length again, L. So we will cut this L by this and it will be 1 upon time, or you can say time inverse. So dimension of dV over dx will be time inverse. Now we will calculate whole dimension. This is force. Force means mass into acceleration. Acceleration equal to velocity upon time. Okay, when you will calculate its dimension, I have already told you in last video how to calculate the dimension of force. So its dimension will be mlt minus 2 upon area. Force upon area. Area means length into length. Okay, so L square upon t power minus 1. mlt minus 2 upon L square into t power minus 1. So what will be? I am erasing this portion. This L square will be goes down. mlt minus 2 over L square t power minus 1. So you can cut 1 L by this power of 1 L. So it will be m. When this remaining L will goes up, its power will be minus 1, and when it will be goes up, its power will be t power minus 1, because it will be positive. Minus 2, this will become positive. Minus 2 plus 1 equal to minus 1. So this is the dimension of viscosity coefficient. What? ml power minus 1 t power minus 1. So student, I hope you got what I want to say. Still, if you are facing any problem, please feel free to call me. I will explain whenever you will ask. Okay, it's so don't hesitate to call me. Okay, so student, now our next topic is the principle of homogeneity. What? Principle of homogeneity. Yes. So what is what it says? According to the principle of homogeneity, in any physical quantity or in any physical equation, dimension of both sides must be equal. What? In any physical equation or any physical quantity, dimension of both sides must be equal. And if any equation consists of more than one term, dimension of each and every term must be same. I am writing the definition in short. What? In any physical equation, you all write, in any physical equation, dimension of both sides must be same. This is first point. According to the principle of homogeneity, dimension of both sides must be same. In which? Any physical equation. In any, according to principle of homogeneity, in any physical equation, dimension of both sides must be same. Second, if any physical equation consists of more than one term, then dimension of each and every term must be same. If any equation consists of more than one term, dimension of each and every term must be same. This is the principle of homogeneity. I hope you all have written. Okay. So beta, what is the meaning of this? I will explain you just after some time, because there is one more topic, that is the application of dimension. In application of dimension, I will explain you this topic. Okay. So just wait. I will explain in detail what is the meaning of this. Okay. So I hope you all have written now. Application of dimension. In application of dimension, I will explain this topic, because beta in many books they are in NCERT, principle of homogeneity is separately given and application of dimension is separately given. And in many books, in reference books, these application of dimension comes under the principle of homogeneity. So don't be confused, both are same. That's why I am explaining. Now the application of dimension. Become one of the most important topic. Many questions come in competitions. So if anyone from you is preparing for the competition for like NEET or other exams, so beta you must watch it very sincerely. Okay, very easy, but you have to pay attention in this video. Okay, student. Okay, and you can say it is also the application of principle of homogeneity. Application of dimension or application of principle of homogeneity, both are same. So beta, what we have three application. First one is to is sorry to convert numerical value of physical quantity from one unit system to one unit system to sorry another unit system, another unit system. This is the first application of dimension or first application of principle of homogeneity. What? To convert numerical value of any physical quantity from one unit system to another unit system. How? I will explain these all topics one by one. Just do it. Second one is to check the correctness of any physical equation. What is the second point? To check the correctness of any physical equation. This is the second point. And student, what is the third point? You write to establish the relation in between or among different physical quantity. What? To establish relation among different physical quantity. Student, I am telling you again, these all three applications are most important applications in exam. Whenever there will be exam, I will give you the question from here. In any competition, if you are preparing for any exam, you must know how to implement these applications. Okay, so but these are very easy, don't be confused. And beta, when I have told you the definition of principle of homogeneity, I have told you that I will explain you later. So whenever I will explain this application, then I will, because this application is same as that of the principle of homogeneity. Okay, so now I am taking first application. The first application is to convert the numerical value of physical quantity from one unit system to another unit system. What is our first application? To convert, I am not writing here, you have to write, to convert numerical value of any physical quantity from one unit system to another unit system. So how we will convert? Students, suppose we have a physical quantity x in one unit system, suppose MKS, any system, FPS, CGS, its numerical value is N1. Suppose, sorry, student, X is the physical quantity. We know that any physical quantity is represented by two terms. One is the numerical value, another one is the unit. Okay, I have given you in first video the example of sugar 1 kg, rice 1 kg sugar. So 1 kg. Okay, okay. Students, suppose in first unit system, जैसे मैंने आपसे I have told you 1 kg sugar. This quantity x is represented by, in first unit system, its numerical value is n1 and its unit is u1. Okay, very simple. In second unit system, its numerical value is n2 and unit is u2, means 1000 ग्राम. दो, मैंने आपको एग्जांपल दिया था कि दो लोग गए, मैंने कहा कि भैया 1 kg शुगर दे दीजिए, दूसरे ने कहा कि भैया 1000 ग्राम शुगर दे दीजिए. दिस इज क्वांटिटी, क्या है? शुगर. बोथ मतलब means in both cases quantity is same, but numerical value and unit is different in both cases. Means if quantity is same, so it means n1 u1 equal to n2 u2. Okay, so our application is to find out the numerical value, to convert the one unit system into the, to find out the numerical value of any physical quantity when we convert it from one unit system to another unit system. Suppose someone asks you what will be the numerical value of this physical quantity x when we convert into it in gram. So how you will find out the numerical value n2? You will find out n2 equal to n1 u1 over u2. This is the simple formula. Okay, to convert physical quantity from to find out the numerical value of any physical quantity from one system to another unit system. Suppose I mean to say, if we have the n1 is the numerical value of physical quantity in first unit system, u1 is the unit of the physical quantity in first unit system, and u2 is the unit of the physical quantity in second unit system. So when we have to find out the value n2, we simply calculate this. Okay, so student, in many books this formula is written like this. Suppose numerical value is n1, u1 is the unit. Suppose this unit is represented by m1 power a, l1 power b, t1 power c. I am writing it here. Don't. I hope you all have written this. What? We have n1 u1 equal to n2 u2. n1 u1 equal to means unit, I already told you, generally in fundamental physics we have only three fundamental quantity. What? Mass, length, time. But when we take all the branches, then we take seven type of fundamental quantity. What are the three basic fundamental physical quantity? Mass, length, time. M1, L1, T1. Power A, power B, power C. N2, M2, L2, T2. Power A, power B, power C. If question is find the numerical value in another unit system, so how we will calculate the n2? N2 equal to L1 M1 over M2 power A, L1 over L2 power B, and T1 over T2 power C. Student, this is the formula. You can write that formula in this form also. Student, very simple. I am giving you an example so you can easily understood what is the how we will implement this. Okay. Student, as in your books, there is the question convert 10 joule into erg. What? We have to convert 10 joule into erg. This. Okay, student, this is the question. We have to convert 10 joule into erg. Means if someone say I have done 10 joule work, so how much will be the numerical value of this 10 joule in the erg? Erg, beta, first we have to know what is this unit system and this is what is this unit system. Beta, this is the SI unit of MKS. SI unit of MKS, and erg is the SI unit of CGS. Or simply you can say it is the MKS unit system and this is the CGS unit system. Okay, and student, this 10 is the numerical value of MKS system or SI unit of MKS system, and joule is the what is uh, whose sorry, whose unit is the joule? Joule is the unit of work. So in work, so in MKS system, unit of work is, I have told in last video, in MKS system unit of work is, sorry, dimension of work is M L2 T power minus 2. So you write here M1 L1 T1. This is for first. Now coming to second, we have to find out how many erg it will be. So N2 equal to question mark. Dimension for second unit system, beta work will be always work. If the dimension will be same, so how we will represent? M2 L2 T2 power minus 2 L2 power 2. Beta, because the unit of work is, sorry, dimension of work is ML2 T power minus 2. Those who don't know how to find out the video, you just watch this video again or you just watch my last video. In that I have explained you detail how we will calculate the dimension. This is the dimension of work. In for first unit system we are represented by 111. For second unit system we are represented by 222. Now I have told you, N1 U1 equal to N2 U2. N1 equal to 10, U1 equal to M1 L1 T power 1, sorry, M1 L1 T power minus 2, M1 L1 का square T1 की power minus 2 equal to, we have to find out the value of N2 and it is M2 L2 square T2 power minus 2. N1 U1 equal to N2 U2. Okay, student. Now we have to find out N2. N2 equal to 10. Divide this side, means divide both sides by this value because I have to find out the value of N2. So you can multiply it cross multiplication. So it will be M1 over M2 power 1, L1 over L2 over L2 both have the square power 2. T1 over T2 power minus 2. Okay, student? So, I am solving this question here. N2 equal to 10. Beta, what is this M1? Mass. In which quantity? In which unit system? I have told you, you watch my video, or I think you have noted, this M1 is representing kilogram because we have 10 joule. Okay, so this is the MK system, meter kilogram second. So this one is the kilogram. And in which unit system M2? This one is in gram. Again, in which unit system L1? Meter. In which unit system L2? Centimeter. In which unit system time? Second. And this one, time is always in second, no problem. Okay, so you can cut this second by second. Better look at here. 10 in 1 kilogram there are 1000 gram. 10 to the power 3 gram upon gram. In 1 meter there are 100 centimeter. 100 means 10 to the power 2 centimeter upon centimeter. You have cut it second by second, so 1 power minus 2 equal to always 1. So now you can cut this gram by gram, you cut by centimeter. Sorry, here power is 2 also. Beta, what I have done, if you find any difficulty, I am explaining. In 1 kilogram there are 1000 gram, 10 to the power 3 gram. So we can easily cut this gram by gram. In 1 meter there are 100 centimeter. 100 centimeter you can easily cut by centimeter, and so you can cut second by second. Now I am writing it here. 10 10 into 10 to the power 3, 10 की power 2 की power का square means 10 to the power 4. By 10 to the power 2 into 10 to the power 2 means when base will be same, power will be added. The 10 की power 2 का square कितना होगा? 10 की power 4. So when base will be same, power will be added. 4 plus 3 7 plus 1 8. 10 to the power 8 arg means value of 10 joule will be equal to the 10 to the power 8 arg, or you can say this 10 joule is in MKS system, and when we will convert this MKS system into the CGS system, it will be equal to the 10 to the power 8. Okay, so this is the application of first principle. This is the first application of dimension. I think student, there is some problem in my mobile of the space, so I will explain you two other applications in next video. So please you all watch my video. Thank you very much.